In this section, I am going to teach you about what are the different types of contacts present inside ANSYS Workbench, and in the next lectures, I am also going to teach you about how to create automatic contacts, how to change the contact behavior when the ANSYS Workbench itself creates automatic contacts, then how to create manual contacts and all other things. Okay, so let's get started with the theory regarding contacts. So first of all, what are contacts? So you have an object here. This is the first object, let us say first object, and this is the second object. Okay, so you have two objects and these two objects are interacting with each other. So by default, the computer cannot tell how these objects are interacting, So in order to teach the computer, or in order to give the condition of their interaction to the computer, we'll use something called as a contacts. And remember, the definition of contact is the same for any software. It doesn't only apply to ANSYS Workbench software. Any software, any FEA software or any modeling software you use, the contacts are used for the single purpose. Simply it can be told as a skin, which is covering the surfaces that are expected to interact with each other. So for example, here the surface is interacting with the surface of this cylinder. So here between these two we have created a contact. And if you are able to see here, two types of colors are there. One is a blue color and the other one is a red color. So this indicates that there is a contact, there is a target. And remember one thing, every contact pair consists of two things. One is a contact face as well as a target surface. So why contacts are required? So see here, there are two bodies, one contact body and one target body, and I apply a force in this direction. So I am applying a force in the downward direction on this contact body. So see here, the first condition is without contact. If I don't give a contact, the computer doesn't know what to do. So I applied the force in this direction, so it will try to move the body in the downward direction. Okay, now we will see what happens without contact. So if I just show you what is happening without contact, this particular contact body, if I apply the force in downward direction, it is going inside the target body and it is returning inside. So is it possible? Is it physically possible that a solid element can penetrate into another element and come back as if it is not even present? No. So in order to simulate the physical interaction between objects, you have to define contact. So now we'll define a contact here, and once we define a contact here, you apply the force. What will happen? The force will travel from this body and it will travel into this particular body. This contact body cannot penetrate this target body, and vice versa. If you apply the force from here, this target body will be moving without contact. It will be moving up and down through this body. But if you again apply a contact and then apply a force in this direction, this target body will transfer all the forces to this body. And not only forces, all the boundary conditions, loading conditions that has to be transferred, especially when an object is containing assembly, number of parts, you need to apply contacts. Okay. If we go to a physical real world problem, here some person is delivering a package where the person is holding the package with his hands. If we want to simulate the same thing in software or a computer, we need to tell the computer that there is a contact between this hand and the package. Otherwise, what will happen? Computer hand cannot hold this package. Likewise, a person is holding an iPad and she is signing with her finger. So in order to tell the computer that the finger is moving on the top surface of this particular iPad screen, or let us say tablet computer screen, we need to give a contact. Physically, when we come to our mechanical systems, let us say here, if you are able to see, here is an gearbox assembly where you can physically see number of interactions. For example, this chain is interacting with the sprocket here. That means that interaction, in order to tell the computer that both of these things are interacting with each other, we need to give a contact. Likewise, here see, gears are there, gears are in contact. So in order to tell the computer that the gears are in contact or they are meshing, we need to give a contact there, right? So likewise, see physically also, when we see this particular valve, what is happening is here the nuts and bolts are in contact. Likewise, if using the bolts and nuts, we are making these two surfaces, surface 1 and surface 2, to be in contact, surface 1 and surface 2 to be in contact. So in order to simulate all these conditions in software, we need to give the contacts. So I think you are able to get an idea of what contacts are and why do we require contacts. So the next thing is we learn about what are the contact types and their contact behaviors that are present inside ANSYS Workbench. Remember, there are 5 types of contacts that are present in ANSYS Workbench, 5 types of contacts, and in those types of contacts also, 2 types are for linear analysis, and 3 types for non-linear analysis. We will see all these 5 types, and remember one thing, any contact behavior can be determined by 2 characteristics, separation and sliding characteristic. So based on the motion that is possible in these 2 ways, you are going to divide the contacts into different types. So first thing, let us say you have 2 objects, contact object and target body, and I apply a contact here between these 2. Because this is the surface where they are interacting, I apply a bonded contact. If I apply a bonded contact and apply a force in this direction, and try to separate these 2 bodies, because it is a bonded contact, you cannot separate these 2 bodies. Likewise, I have 2 bodies again, I apply the force in the tangential direction or axial direction, and I try to move this contact body over the target body. But remember, we have given a bonded contact. That means what will happen? This contact body cannot move on the target body. That means separation is not allowed in bonded contact. As well as sliding is also not allowed. Okay. These 2 things are not allowed. Simply remember, bonded contact is nothing but you take 2 objects, you glue them together so that they will act as a single part. That is the thing we are simulating in the bonded contact. And this bonded contact by default is a linear contact, and this is present in every FEA software. And for linear analysis, most of the cases we will be using the bonded contact. Then the next type of contact we are going to see is called as a no separation contact. And you can see this is also a linear contact. But what is the change between the bonded contact and the linear contact? See here, as the name states that no separation, that means if I apply the force in the transverse direction or normal direction and I apply a no separation contact here, what will happen? This contact body cannot be separated from the target body, means no separation allowed. But if I apply the force in the axial direction or tangential direction, what will happen? This body can slide over the target body. See, if I apply the force in this direction, this body can slide over the target body based on the force you have given. Okay, so sliding is allowed. Okay. So the difference between no separation and bonded contact is, in both of the bonded contact as well as no separation contact, we cannot separate the 2 bodies. But there in bonded contact, we cannot slide the body. Here we can allow the body to slide over each other. And in specific cases, we are also going to use the no separation contact. But most of the cases, linear analysis, we will go for bonded contact. And remember, by default, what are the automatic contacts that will be created by ANSYS Workbench? They will be in bonded type. You have to manually change them to other types if you want to change it. Alright. The next type of contact we are going to see is the frictionless contact, and this is the non-linear contact. Okay, this is the first type of non-linear contact. and here also anyway as usual we'll see the separation direction, we'll see the sliding characteristic, and we'll see how it behaves. So remember, I will apply the frictionless contact here between the contact body and the target body. Here also I will apply the frictionless contact. Now what will happen? See, even though you apply the frictionless contact and apply the force in the transverse or normal direction, what is happening? This contact is allowing for the separation to occur. That means separation is allowed. Separation is allowed. Okay. Likewise, if you see, I apply the frictionless contact and I apply the force here, then I will try to, I apply the force in the axial direction and I will try to move the body. As we apply the frictionless contact, this contact body is sliding over the target body, So that means sliding is also allowed. But here what is happening is the coefficient friction is 0. Frictionless means the coefficient of friction is 0. That means there is a smooth interface between the contact body and the target body. The contact body cannot penetrate the target body, but it can slide easily, very smoothly over the target body. Likewise, it can get separated from the target body. But remember, once we apply the contact, this contact body or this target body cannot penetrate each other. Okay, so remember the mu is 0. Why this is nonlinear contact means, see here, as this is allowing for the separation, what will happen is multiple iterations are required to solve this problem. Multiple iterations are required to solve this contact equations, and also because separation is there, K stiffness value will change. And don't worry about all these things, just remember that separation is allowed as well as sliding is allowed, and sliding is allowed in a very smooth frictionless way. So that is the behavior of a frictionless contact. Then the next type of contact we are going to see is the frictional contact, and this is another type of nonlinear contact. Now we'll see, when we apply the contact here between these two bodies, and here also I apply the contact between these two bodies, and I apply the force in the normal direction, I will see what happens here also. Like in the frictionless contact, it is allowing for separation. Separation is allowed. Likewise, if I apply the force in the tangential or axial direction, what will happen? This contact body can slide over the target body. Sliding allowed. But you might ask, what is the difference between frictionless and frictional? So as the name suggested, here you are going to have a mu value, that is coefficient of friction value greater than 0. That means there is some type of friction, some kind of friction between the contact body and the target body, so that the sliding will not be as smooth as in the frictionless contact. That is the only difference. Here you will have to give the mu value. You will be manually giving the mu value, manually supplying this. Okay, so this is the frictional nonlinear contact. And next one is rough contact, and this is also a nonlinear contact. So again, what I will do, as usual, I will take two bodies, I will apply the rough contact here between these two bodies, and I will try to apply the force in this direction, and I will try to move the body. So see here, when I try to move the body, obviously it is moving. That means here also separation is allowed. Okay, separation is allowed. But if I come here and apply the force, and I try to move this body cannot slide over the target body. That means sliding not allowed. Why? Because when we apply the rough contact, it will take a mu value which is equal to infinity. That means mu infinity means very high friction. On that very high friction, the contact body cannot slide over the target body. So this is another type of nonlinear contact. So finally, to summarize, Finally, to summarize the contacts and their behavior, we have bonded contact, rough contact, no separation contact, frictional contact, and frictionless contact. So here this is a linear contact, linear. This is a non-linear one. This is also non-linear one, non-linear. This also non-linear. Okay, this is a linear one. Okay, linear type of contact. Gap means separation. Is separation allowed or not? In bonded, it is not allowed. In rough, yes, it is allowed. In no separation, as the name states, separation can be allowed. No. In frictionless and frictional, both this can be allowed. This can be allowed. Coming to the sliding behavior. So in bonded contact, as I told you, nothing is possible. Even the separation or the sliding is possible. Rough, sliding is not possible. Sliding is not possible. Even though it is, yes, it is not possible because of the presence of very high amount of coefficient of friction. Very high amount of coefficient friction which you can't change manually. So obviously we can estimate that sliding can't happen. Then coming to the no separation, sliding is allowed, but we'll take the mu equal to 0. Likewise, it is somewhat like a frictionless contact in terms of sliding behavior, but the difference between the frictionless and no separation comes from the fact that in frictionless contact the separation is allowed. That is the only difference. Here sliding behavior is same for no separation and frictionless contact. Then coming to frictional contact, anyway it is a nonlinear contact, that means separation can be given, that is not a problem, and the sliding behavior is allowed. But the condition should be the mu friction of sliding should be greater than the mu of friction. And remember, these are the 5 types of contacts that are present inside ANSYS Workbench, and in the next lectures we are going to see how we can create automatic and manual contacts using the ANSYS Workbench software. I hope you got a good idea over different types of contacts, why they are required and what are their behaviors.